Welcome, everybody. Thanks for coming. It's a big day for us, and so it's really cool to see everyone here to learn a little bit more about Dart. Sorry for the late start here. We're just in our Q&A session. And you might notice the app update there. Our company pushed a update to our operating system last week, and I said, there's no way I'm updating this right before this huge demo in front of everyone. So that's going to be our friend during this presentation. And if I make it go away, it comes right back. So anyway. So this is mobile multiplayer HTML5 Dart. Check, 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 check. My name is Seth Ladd. I'm a developer advocate with the Chrome and Dart team. And I was here last year, and it was really cool to see everyone. I got my background in Java and really got used to the productive tools and structured language and things like refactoring and code completion. And then I got the job at Chrome and learned all about the modern web, but really missed that productive programming experience. And so when I heard about this Dart project, I jumped all over it because it allowed me to get the programming experience that met my expectations, but still build for the most ubiquitous platform out there. So I want to share some of that story with you. So as we saw here, and I made this presentation and signed up before I knew we were launching. So I should have done an intro to Dart, but luckily we heard a lot about that this morning. So Dart, as we saw, is much more than a language. It's essentially batteries-included platform. Things like productive libraries, very consistent and comprehensive. Things like productive tools, a package manager, an editor, an analyzer, a virtual machine to run Dart code natively, but most importantly, a compiler to JavaScript. I believe this is one of the most important things we can do, allowing you to see everything that you're going to see here today in the presentation and get it out onto the modern web. And we saw Dart V1 get launched today. This is huge for our team. Hopefully you guys will really enjoy it. And so it's a big deal for us, and hopefully you guys, it's a big deal for you as well. Now, it was really cool in my role in developer relations as we led up to this 1.0 release to work with various partners to help them get up and running and get their apps out today as well. And so I saw some really magical things being built with the Dart platform. Soundtrap is one, and they really liked the quick prototyping that Dart allowed them to do. We saw a montage from Mixbook, and they really liked the familiar language and the cohesive set of libraries, and we were happy to hear that. We heard from Blossom, who really liked the sane and consistent development experience. And again, that's what we're trying to do. Now this one's really cool. We heard a little bit about Stage XL. This is, Flash games are prevalent on the web. Obviously on mobile there's no Flash VM, so people are looking for alternatives, and authors like for Stage XL have seen Dart as a natural evolution from their ActionScript code. So the feedback here is it took him only 6 hours to port a game, and it turned out to be 20% smaller than the equivalent ActionScript 3, and that's this game right here. Speaking of ActionScript, Flash and Adobe were so impressed by that Stage XL library that they bundled it into an extension to Flash Pro. So you can author in Flash Pro and use their really great tools for timeline management, asset management, animation, and instead of writing ActionScript 3, you actually write Dart code. And then when you export the whole thing out, it gets the HTML5, CSS, and Dart, thus allowing you to author in Flash Pro and get to the modern web. The tool ecosystem is growing. Tools like WebStorm, and they're here at the show today, have Dart plugins, yay, thank you, built right in, comes right out of the box. We also heard from Angular, a very popular framework for building dynamic and really embracing HTML applications, has been ported to Dart as well. And we heard this story from Brad Green earlier about his team that rewrote Google's internal CRM tool in just 6 months from scratch using Dart and Angular. So maybe you guys want to check out Angular Dart. But I mean, it's rewarding to work with partners like that. It's rewarding to see the community and ecosystem grow. But we got a little jealous. My team in developer relations, we said, it's one thing to help everyone else, but we want to write cool stuff too. We want to try out this platform and make something really fun. At the same time we had that realization, we started playing a game. This is Boggle. It's a tile-based word-forming game. It's a bunch of letters, and you try to find words. Well, this kind of swept through my team like wildfire, and I think it's fair to say that we got pretty addicted to this game, maybe doing this a little too much than actually working for a couple weeks there. But anyway, it was really fun, and we really liked it. We said, perfect. We want to write a Dart app from scratch, start to finish, client server. Let's port this game to Dart. So that decision was pretty easy, but we didn't stop there. We said, all right, if we're going to build this thing from scratch, let's see what else we can learn from this experience. And we took a step back and say, what's the trends here? What's happening? Well, there's some key stats that really drove our decision to not only build a just regular web app, but to build a mobile web app. So some of the things that really made us sit up in our chairs, here's an example. IDC expects that tablet shipments will surpass desktop PCs in 2013 and portable PCs in 2014. That's pretty clear. Okay, 48% of Facebook users on a given day access Facebook via the mobile app. From mobile. So almost half of all Facebook access is via a mobile device. That's a definite wake-up call. Now, this one's interesting. In the US alone, 93% more time was spent online in just the 3-year period, but 80% of that growth was from mobile devices. So who here is building on mobile today? They're building for mobile. Oh, that's great. Okay, this is more than we saw last year, and I suspect that number will double again in just a year. So it was obvious that we needed to build this app not only in Dart all the way through and through, but make sure it worked on mobile. And that's just what we did. We built our game we affectionately call Word Herd on phones and tablets. We also, of course, made it work on the desktop. Firefox, Chrome, and Safari as examples here. And I would like to give you a demo. So I'm going to walk up to this screen here. So this is the Nexus 5. Is this good enough? Okay. Tell me if I need to get closer. Okay, cool. This is the Nexus 5, and one thing you might notice is the airplane mode is on. So I am totally offline here. I'm not even connected, but I'm still able to play the game. So let's play, let's start a new game, start a new solo game. Yell out if you see something, par. So touch works, that's pretty cool. Pans, I should probably stop. Sane. Okay, updating the score correctly. So here's another great thing about this. Notice how I'm doing this, and the page is not zooming in and out. So I'll show you guys how to do this. This is a huge technique that you want to employ when you build modern web apps. And again, remember, it's all working offline. Sure, I want to end the game, and it shows me all the words that I got. Okay, so this game's working offline. Let me go over here. Now, what I want to show you here, I mean, we saw all that basic functionality, but this is a Nexus 7, so the screen is a little larger. And this is Chrome for Android, just like we just saw earlier. So that was a Dart app compiled to JavaScript, running offline in these browsers. But the important thing here, let's start a new game, is that the screen is the game board is adapting the size. So we'll show you some techniques as well for creating adaptive but fixed layout game experiences here. I mean, notice how I can't, well, I mean, I can do that, but it's not acting like a web page. It's acting like a web app. So it's a slight subtle design difference. So that's just working on the Nexus 7. The last thing I want to show, though, I should be online here, so let's actually go to the game. Okay, great. So we saw touch, we saw phone, we saw tablet, but that was all offline. I just want to show you that the game works online as well and works with the keyboard. So let's start a new multiplayer game. This is using Google+, so I authenticated via Google+, and then it goes into, once it knows all my friends on Google+, and then goes back into the database on the Word Herd side, which is actually running also Dart, and then finds people that I know have also played the game, and I'm going to create a new game with them, and boom, it's the same game board here that we saw in the single player and the offline experiences. So another big theme here for us was reusability, and you get that with a language that gives you the structure and components on the UI as well. But just to show you, keyboard works as well, and notice how it highlights the path and does the score. So, oh, yeah, thank you. Yep. Good. Thanks. Okay, so that's the demo. You can see the, sorry, I missed the, you can see that the game works online, offline, has a client piece and a server piece, and works on phone, tablet, and desktop with both touch and keyboard. This is all built with Dart, HTML5, and all compiled to JavaScript, except for the server piece running on the Dart VM. So let's look at the architecture of this. How did we make this happen, Dart through and through? We have the Dart VM running on the server. He's connecting to his database, in this case, Postgres. We have Dart compiled the JavaScript on the client, and he's connecting to his local client-side database. If you're running in Chrome, that's going to be IndexedDB, and if you're running in Safari, that's going to be WebSQL. Both the client and the server are authenticating with Google+. In fact, you authenticate on the client side, and then you send that token over to the server, and the server then validates who you are, and then now you have a token on both ends. A really cool thing about using the same language and the same libraries on the client and server is you get to reuse code. So we have a large chunk of code in there in the middle, shared libraries from both the client and the server. And then the data sending back and forth and from client and server is just JSON serialized Dart objects, something a pretty standard technique there. So this is the basic high-level architecture of this game. So let's start our case study now with the Dart syntax. How did we use the syntax? What features did we use the syntax? What features did we use and what worked for us? Well, as you probably saw earlier, the Dart syntax is very familiar. We did this on purpose. We wanted you to learn this in about an hour or two. We've run numerous internal and external hackathons. People get up and running very quickly. We have semicolons. We have curly braces. It's all there. In fact, we got a little flack when we first launched Dart. People were like, why didn't you make the world's next Haskell? And we're like, we want more than 5 users. So we wanted to make a language. You guys, everyone here is like, OK, I got it. So this is probably pretty quick. Class-based, also single inheritance, very familiar to everyone here, I think. But creating a new language is also an opportunity for us to add in a little bit new, right? It doesn't have to be a direct sort of clone of what you're already familiar with. So Dart has a concept of mix-ins. Mix-ins are really powerful because it allows you to avoid polluting the inheritance hierarchy. And now some frameworks out there might force you to extend some sort of functionality class. In Dart, you don't have to do that. You can keep your inheritance tree as a simple, clean is-a relationship and slide in functionality like observability or persistability, slide it in with a mix-in. Fields in Dart look very standard, and hopefully this is very familiar to you. We also have the concept of metadata, again, something you're familiar with. And in this case here, we're marking the score field as observable. And if you remember, as I was playing words on my board, the score was auto-updating. That's all from the observability system, which we'll dive in more when we look at the client. Creating methods looks very familiar, so no real surprises here. It's part of its strength. Okay, so now we're getting into something that's a little bit newer maybe for some of you. Dart has function literals. So what you're seeing here is we want to add up all the score of these words and get an absolute score. And so we loop through each one and reduce the score down to a single score. And total and score are the parameters to this function literal, and I'm returning, that's what the fat arrow says, the total plus score. So it's a nice, terse way to put, you don't have to use anonymous inner classes in there, a nice, terse way to make reusable chunks. We talked about fat arrow as well. It's a nice syntactic sugar for curly brace, return expression, curly brace. And another really nice feature of Dart is its string interpolation. This is a nicer way to do string concatenation or string building. You don't have to use the pluses. You don't have to use string builders all the time. Just $ variable or $ curly brace expression, and it will construct the string for you. So we definitely took advantage of a lot of language features. Now, you might have noticed here that up to this point, there was no getters and setters. Now, this is a really nice feature. You might be very familiar with defensively creating getters and setters in your Java code, just in case something might change, so I want to hide that implementation. Well, Dart says, go ahead and start with fields, like we do here, and we'll implicitly add getters and setters for you. Now, you can replace those implicit getters and setters with explicit getters and setters if at some point you need to change the implementation of that field. But you don't have to defensively do this, and it's such a saver in terms of lines of code. But you can create your own getters and setters like we do here. I wanted to get just the words from this game, and so I hide words.keys, and notice how I can use game.justWords. It looks like a field access, but it's going through a getter. So I love the typing. Well, what other features of Dart language did we take advantage of? Well, this is one of my favorites. People really love this, method cascades. In this particular case, we're creating a game match. This is a multiplayer game, so I need to set up different players. I need to set up different player names, different games, set the board. This is a lot of like a builder type API. Well, with method cascades here, notice I don't have to repeat the variable name. In fact, all these different setters are cascaded off of new game match. And then that whole expression is set to match. So it's a nice way to work with builder APIs. In fact, it's a nice way you get essentially the Fluent style APIs for free from the language. You no longer have to explicitly opt into returning this from every call. You can just simply rely on method cascades to make it a lot easier. But you don't have to use method cascades just for builder type APIs. Sometimes they're good just for repeating redundancy. In this particular case, the server side of WordHerd had to set CORS headers. CORS headers allows another client from a different domain to access those resources. And I have to set 4. They're kind of verbose and long here. So instead of repeating rec.response.headers 4 times, I can use those cascades and significantly reduce the amount of repetition in my code. So pretty big win there for us. Also on the terse side of things, Dart supports collection literals. So here we're passing in right there a literal map with 2 keys and values, so I don't have to go first create new map, new hash map, and set them one by one. It also supports literal lists as well. Just nice things that you would find in a scripting language to make you just program a little bit faster, type a little bit less, are available here in a structured language like Dart. Okay, so we saw function literals earlier, but they're also closures. And so I use these a lot, especially in async style programming in the game. In this particular case, I wanted to get all the matches, and this is an HTTP request handler. But the important thing is here, I get all the matches from my persistable layer, but then, when all those matches are available, send JSON. But notice here that the request available in send.json, which is inside that function literal, is closing around the request that comes in from get all matches. So this is really nice. I don't have to somehow introduce another variable by hand. That scoping, that lexical scoping and closures just works. So we were happy with the language and the syntax. So let's look at how we employed the different language features and platform features to enable or facilitate code sharing, which is really important if you want to use the same language on the client and the server. A big part of this, and a big part of all healthy ecosystems, is the package management system. Obviously, Java has Maven, Ruby has Ruby on Rails, Python has eggs, JavaScript and Node have NPM. So, of course, Dart has pub, because you play darts in a pub. And pub is where you can host packages, you can download and install packages, you can upgrade packages, share packages, packages being essentially zips or just directories of Dart code. And it's a really good way to share out code that you've written or consume code that others have written, similar to other great ecosystems that allow that great third-party sharing. So the game itself, WordHerd, is itself a pubspec.yaml file, is itself a package, and you define a package with a pubspec.yaml file. YAML being a very simple markup language, key values. I think the important thing here is when I'm pointing to the environment SDK configuration. It shows one of the strengths of pub. It has both semantic versioning and really great support for ranges. Semantic versioning being a convention that the community can all rally behind, saying major versions are for breaking changes and minor versions are for API changes that might break, and then ... releases or just point releases. If you prescribe to that, it's a great way to advertise to the outside world what this new version of your package is capable of doing, either adding features or potentially breaking customers. So then you can use Pub's expressive version ranges to say, okay, I'm only guaranteeing that my particular app works up to this version here and none lesser. And it's a nice way to lock down exactly which version of which packages you want to use. Now, our application itself uses a lot of third-party dependencies, and these are other packages, which you can define here in the pubspec YAML file. These packages themselves can live in pub.dartlang.org. This is our own hosting service for packages, and people can upload and download from there. Already 500 plus packages, ranging from everything from game libraries to crypto libraries, the server-side frameworks, client-side frameworks, database drivers, you name it. It's really cool to see the community already get started there. Packages can also live on Git and the local file system, giving you lots of options on how do you consume and organize and create reusable chunks of code. So specifically for WordHerd, we used at least 14 different packages from the community and from the Dart team. Everything from the HTTP server to the routing system to, again, the game libraries, client-side persistence. I think the point here, though, is this is all code I did not have to write, which was awesome. As much as I would like to just write Dart games all day, my boss would probably be like, you have other stuff to do. So it was really nice to be able to get a real big leg up and reuse what the community's already published for us. So thanks, package authors. You definitely make it easy to get started with Dart. So packages are one way to share code in the Dart world. Another way to share code is through just shared libraries. Now, again, we've been talking about how Dart on the server is running the server-side component of the game, and Dart on the client is running the client-side component of the game. But they both talk about the same kind of objects, right? Games, boards, players, matches. So why can't I just create those in one library and share them in both directions? So let's see a little bit about how they do this. So Dart has the feature of libraries, allowing you to namespace or collect constructs like classes and top-level functions. On the server here, we're going to create a library called WordHerd Shared, and we're going to import a server-specific library. So you can import libraries, but we're also going to pull in common code like game and board. Over on the client side, I have something very similar. I have a library for the client. Really, the only difference is does he pull in a server-specific or client-specific library? But notice how he has game and board as the exact same files. And they both literally point to the same game and board and those. And this is how I can create Dart classes that are shared across two different, otherwise disparate libraries that may run in two different, totally different runtimes. So that's how I share just straight up Dart code in two different libraries in two different environments. But what if you have the case where you have a common interface? Then you want to share that interface across runtimes, but the implementation of that interface or implementation of that class is totally different. In this particular case, let's look at persistable. As an example of persistable on the database is implemented with Postgres. Persistable on the client side is implemented with LawnDart, my library to get on top of IndexedDB or WebSQL, et cetera. But I want that API to player to be totally the same. So I want to call load and I want to call store exactly the same way in both environments. And I don't want to care about whatever the difference in implementations are. So how do I share an interface but not share an implementation? So in this case here, I have two specific files, one server-specific and one client-specific. In the server-specific one, well, in both cases, they are the same class with the same API. Persistable, load, store, they both have an ID. So from the outside world, they look like a regular persistable object. But the server instance of this, or the server definition of persistable, has Postgres code inside, and the client implementation of persistable has IndexedDB or WebSQL code inside. So that's how I was able to share the same type of interface across two different, very different environments. Okay, so we're talking a little bit about the server. Let's dive in. What exactly did we learn or experience with building Dart on the server for this game? Well, it's really, really cool because the Dart VM runs on the command line, can spawn up servers, but the Dart VM runs source code. No compiles are needed. Very fast iteration times. It's just like Ruby or Python or JavaScript. You just say Ruby space that script, runs and executes. You just say Dart space that script, execute. Very, very fast. The Dart I/O library allows you to get access to files, directories, sockets, SSL, HTTP, WebSockets, all those core fundamentals at the OS level, and take advantage of that actual operating system and write real servers. And the Dart VM has, and much like on the client side, an async style programming experience. It's similar in spirit to Node, which is an async style, but I think that the programming experience in Dart and the Dart VM is much nicer, and I'll talk about why. So this you might think, okay, async, right? That's a bunch of callbacks. So you might think of code like this. db.init, and then when that's done, load some data, and then take a callback from when load data is done, and then bind to a server, and when that's done, take a callback, and then, okay, I can finally start handling requests. But there's a couple issues with this, right? Way too nested. This is getting hard to read. There's no apparent, well, there's no error handling here. Also, where would I put that? And this is the classic example of callback hell. This is getting just a little too confusing. So luckily, in the Dart world, we have an object-oriented concept to callbacks we call futures, very similar to promises or deferreds in other languages. So instead of taking callbacks, return an instance of a future. In this case here, we've returned a future, and then is called when that future completes with a value. So I can say, do some async thing, then run some next async step, then another async step. Notice how I don't have that deep nesting anymore. I can just simply list them or chain these calls to then. And remember earlier, I was like, how do I handle errors here? Well, in futures, you can put at the end of that chain of thens, you can put one catch error. And any error that happened along that chain of futures, if an error happens, it kind of pops out, and catch error captures it. And at the very end, you can optionally put in a when complete. Now, if we look at this and sort of squint, you can see this asynchronous code here is similar to what you might have written in this synchronous code over here on the right. Do thing, next step, another step, catch some potential exception, handle that error, and then finally run this. So finally and when complete are very similar, catch error and catch are very similar, and the thens are what you would probably put inside your try. So it makes writing asynchronous code that has to deal with single values that may come into existence later much, much easier. So we can turn that old version of that deeply nested, just set up my server and get going, into this because I can use futures. So db init, then load the data I need for the server, then bind the server, then, okay, now my server's ready, and if any error happened along that way, go ahead and catch the error. I don't know about you, but this, to me, is a lot easier to read. But futures are just for one-shot events, just one value that might occur in the future. But we also have a really nice object-oriented abstraction for streams or reoccurring events, things that would happen over and over and over. So let's look at how we're going to use streams here. So this is just an abstract example. Some event source is going to give back a stream. And on that stream, you can listen for events. And every time you have an event, this callback is fired, and you can handle that event. It also has really simple ways to handle that error for any events that happen on the stream. So, okay, nice simple API for a stream of events. But the API gets way more functional and way more useful when you start to look at, oh, I can filter these things. I can transform these things. I don't have to work with just a raw stream. So one example here, again, an abstract example, is on some message, okay, where, this is the filter. Let's say you want to filter this stream, and you only care about the critical messages. Then I want to convert those critical messages. I don't care about the crazy met code. I actually want a nice human-readable string. So I'm going to turn that filtered stream into a converted stream using map, which of course returns a stream again. And then finally, I can listen to that stream, which has been filtered and has been converted. And at the very end, I can notify on call of those filtered and converted messages. So this is a really nice and expressive API, chainable API for dealing with events. Okay, so that's in the abstract futures and streams. How did we actually use that in our server for word herd? Bear with me here. We're going to get through this. So I want to show you a real-life example I took from the code. In this particular case, get all friends. So I'm connected to Google Plus and return a stream of friends. So now I have these friend objects or person object, I think they are, and it's a stream. Now, I actually just care about the full list of those, so I can turn a stream into a list. And so I can call toList. Now, that returns a future, so when the stream's done, put everything in the list. And then, once I have a list of all of the players that I'm friends with, I want to take those players and look them up in my database. So then go correlate who also plays word herd. And I have to wait for that, of course. Now, it's going to fire off a whole bunch of different database queries. And one of the nice things about futures, because they're object-oriented, I can say, wait for all of the futures to be done, because I have a handle on each one of those objects. So future.wait, all of the queries. So when all those queries are done, then I can finally take them and send them off as JSON back up to the client and say, here's all the people who are also your friends in Google Plus and have played the game and a nice JSON stream. Of course, we have catch error. This is a real-life example using streams and futures and highly asynchronous programming, and hopefully it's fairly easy to follow along. Real-life example from our server. So we mentioned that futures and streams come from the core library. I mean, this is built into the core of Dart. So all libraries and all packages that needed to deal with asynchronous programming in Dart use futures and streams. A good example of that are the database queries. So of course, anytime you do any kind of I/O, you want that to be asynchronous. So let's dive in a little bit into the database on the server side. So I'm a simple man, and I had a simple desire here when I worked on the persistable part of this server. I didn't want to write any code by hand. I don't like writing SQL queries, and I don't like writing verbose mappings. I want to dynamically build SQL queries. I want to dynamically create new instances. I want to dynamically set fields on those instances. The system should do all this work for me. So how do I dynamically create instances? How do I dynamically set fields? Well, luckily Dart ships with a reflection system we call mirrors. Now, mirrors allows you to do a couple of things. Classes, objects, fields, libraries, variables, those all can have their mirror counterpart. So it's kind of a cool concept to think all the things in your system, each one of those can have a mirror that can reflect on that thing. Mirrors can reflect on the structure of your application, but mirrors can also, you can use mirrors to also dynamically invoke methods or fields as well. So it's a really nice tool for dynamic or meta-programming. Okay, so how do we use mirrors in conjunction with our database system so that I don't have to write any lengthy boilerplate code? All right, so let's take an example here, find by. This is a method on persistable. This probably makes sense, like find this type by this ID. One thing I won't go into, I can show you guys later, but we're going to build a query. This just builds the SQL query. So this goes into the database and runs the right Postgres query to find all the column names. So he's built the kind of raw query here for me. Next, we reflect on that type. The type being, like in this case, person or game. And I get that class mirror back. And then I'm going to execute that query. And now that we know about futures and streams, this map call here is mapping the stream of rows that I get back from the raw database query. That's what this guy is. And I'm going to, for each row, go into create and populate. Now, this is dynamically creating instances and dynamically populating those instances based on that row information I got back. So let's look at a little bit at how that works. You don't have to read all this code, but I'll just point at the main concepts here. So in create and populate, I call the default constructor here. So I'm creating a new instance based on that class mirror. And now I have an actual persistable object I've created from the mirror. Then, for every field in that row that I got back from the database, dynamically invoke that setter on the new object I just created, which populates it from all the data in the database. And then that's it. So this is the code to reflectively create new instances and populate them from a database row. It was really great, and I didn't have to write a whole bunch of mappings everywhere. So I was pretty happy with Dart on the server. Well, let's talk about Dart on the client. A lot of activities happening there. What did we use? How did it work for us? I like to start it off talking about this real-world problem. The version on the left is Gmail. And it's obvious that it's Gmail. I'm sure you guys can tell from all those divs. This is something I don't really want to see on the web. Search engines can't crawl this. It's tremendously verbose. It means nothing. The semantic structure is lost. The version on the right, though, is the world that I want to help build, and the world that I think you guys would probably want too. Instead of div soup, divs all the way down, you probably want messages and message and subject, and actual tags that have meaning, and actually have encapsulation, and are readable and indexable, and actually components and widgets you can use. So hopefully you guys agree that the version on the right is the one that you want to build. So we can enable this world by using the emerging new set of specifications collectively called web components. And a big part of web components is to be able to create custom elements. Custom elements have actual encapsulation for perhaps the first time in actual web development. Before this point, if you included a CSS file in your page, those styles would just go all over everything. And now with web components, you can encapsulate the structure. You can build a component out of other HTML elements or other components. You can also encapsulate the behavior of a custom element. You can give it an API you could programmatically call. You can also encapsulate the styles of a custom element. So yes, you can actually have a specific style for your P that only affects the style for this custom element right here and does not bleed out to the rest of the document. These custom elements are highly reusable. They're also working on a specification called HTML imports, which allows you to take a custom element, which itself is defined as HTML, and import it into any number of other HTML pages, allowing real reusability. And something that the Polymer project, which is an implementation of these new web components, allows you to do is data binding. Data bind between models, and DOM nodes. And when something changes, update the other and vice versa. And this is something like the Angular system has really done well and shown us the power of data binding. We're getting as well in the web components world. But maybe most importantly about all this is that these technologies, these are future-proof technologies. These are built on emerging actual spec track features like shadow DOM, custom elements, HTML imports, the template tag. These are things on W3C and What Working Group that multiple browser vendors are working on, multiple browser vendors are editing and getting behind and supporting. So what you're seeing here is not Dart specific. It's for the modern web, and that's really cool. It's just that you can use all this stuff today, right now. And we can use it today, right now, which I guess is pretty redundant, with the Polymer project. The Polymer project is an implementation, a pretty tall stack actually, an implementation of low-level web component platform primitives. And as you go up and higher, more syntactic sugar, then more custom elements and applications. Polymer.Dart is an implementation of Polymer for the Dart developer. And so far we've been working on the red layer here, which is the foundation layer. These are the actual polyfills for those new specifications, things like shadow DOM and HTML imports. And then the yellow layer there, which is the kind of syntactic sugar over the red layer. Our goal is to get the red layer to disappear as more browsers implement more of these actual web specs natively. So how do we use these things? What do we do with them? Well, it turns out we can use custom elements everywhere. We use them for things like initializing or setting up our database. That's now a custom element. We used it for loading up the assets. That's a custom element. The app itself is a custom element. Rendering out the Google Plus sign-in button, that's a custom element. So we kind of went custom element crazy. But it worked out great. So maybe the thing that I think, one of my favorite elements here is maybe one of the most simple elements that were created, but it really highlights the power. So let's look at a custom element for online and offline. When online, that's a custom element. When offline, that's a custom element. And these do what you think they do. When I'm online, show this content or make this visible. When I'm offline, show this or make this visible. Well, how do we implement it? I create a Polymer element named when online, and you can already see I'm using HTML to create new HTML. That's kind of a core concept here with web components. If I already have a mechanism for making it happen, use that mechanism. Inside when online, or inside every custom element, you have a template. This is that encapsulated structure for the custom element. And inside the template, I'm saying, okay, if I'm online, do some dynamic data binding. Is online is a field that I'm binding to. That's what the double mustaches do. And then template if just says if that expression returns true, then render out what's inside. And if the template expression is false, then remove that. And content here says whatever is the content of my custom element. Now, these custom elements can also be backed by a Dart class. In fact, this is one of the great uses of classes. You can almost think of this Polymer element here as a class that you can instantiate by creating new instances of. And so, of course, it makes sense that I have a Dart class to back the Polymer element. This is what the class looks like for when online. We have observable fields. So is online, that's an observable field. And inside of one of the lifecycle methods of this custom component, I can look at the new browser APIs like window.navigator.online and set that field. Is online true? So really, this is just wrapping HTML5 features that already give me the ability to detect when I'm online or detect when I'm offline. Instead of putting this functionality somewhere in some utility library or whatever, I'm nicely encapsulated inside of a tag that clearly expresses my intent. So that's one component of offline, but there's this key piece to make your game or app work offline, which is the app cache. This is really what turns it on. The app cache is a manifest that, I'll just skip to here, lists declaratively every single resource your application needs to work. Now, the browser will see that your game or app has this app cache. He'll then download each one of these assets, store them in a separate cache. And then the next time you visit that main URL, he's like, oh, I have a cache for that. He will bypass going to the server. He'll instead go to the cache. So on that second load, it's instantaneous, and it even works when you're completely disconnected. Now you can bind this application cast into the HTML tag just using this manifest, and there you go, that's it. Now you've told it this page, you've told the browser that this page can be run offline as long as it first fetches all of those resources. And you saw that work with these devices here, so all modern browsers do that. So that's one piece. The online is offline detection is another piece. The final piece here for offline capabilities is how do I store state offline? So app cache is just for storing resources like images and CSS and JavaScript. But as we saw earlier, we have this concept of persistability, and I want to use the same interface for persistable on the client and the server. On the client, I want to store things like games. We saw that earlier. I was playing offline solo games. Those are being stored into the local system, the local browser's database. But the tricky part with browsers is there's no one modern cross-browser database that works everywhere. So I built a library called Dart that allows you to mask the differences between IndexedDB and WebSQL and even local storage so that it doesn't matter. As long as you're on a browser, you're going to get offline. And I implement persistable on the client with Dart. OK, moving on the client here. Probably the most important thing you can do for building mobile web experiences is to understand this concept of viewport. So we've kind of left now the back-end world, like persistability and how to make offline. And now we're talking squarely about how to make that game actually render onto my screen. In fact, you saw earlier that it looked good on the tablet, looked good on the phone, even those were different sizes. Even if I tried to like pinch zoom in, none of that worked. It was nice and steady. Well, it turns out that by default, mobile browsers assume that your page or app is built for the desktop. And you can see here the version on the left, it doesn't do such a hot job at figuring out the right thing to do. But you can tell the mobile browsers, no, I thought about this, and this is a mobile page, and I'll show you how to do this. And then the browser's like, oh, OK, got it, you thought about this, so you can instead make your game actually work correctly, the version on the right. And this was like voodoo to me that I'm really glad I figured out, so I want to share this with you. If you take anything away from this talk, other than you should use Dart and it's 1.0, it's probably that you should probably go look up viewport. This meta tag here, it tells the mobile browser, oh, OK, you are mobile friendly. There's a bunch of different options in here. We're not going to go into all of them, but make sure you look up viewport. It disables the pinch zooming experience, which is exactly what you want for apps. Otherwise, the browser is going to do a bunch of zooming automatically for you, and it disables that. And it has proper scaling and layout for you. So the typical patterns up here, device width, user scalable, no, initial scalable, yes. OK, now my game looks really great and works like an actual app in a mobile browser. OK, great. So one thing that we learned when we were building this game is it's one thing to just test on your desktop device. I mean, that works for a majority. Whoa, hello. That works for a majority of cases, but when you're ready to get actually building on your mobile device, or building the mobile piece, nothing beats actually testing on a real device. And I want to show you first how I close that. OK. Where did I go? OK. I want to show you how to use Chrome's dev tools to both remote debug and remote reverse port forwarding. That is, how to actually develop on your desktop, but test on your mobile device with absolute pleasure. So let's dive in and see if this demo works. Absolute pleasure. OK. Where did we go? Where did we go? Over here. And we're here. Good. OK, I have plugged in my phone here, just a USB cable. And here I have, sorry, you probably can't see this. Here I have a normal Chrome. Doesn't know anything about Dart. Hopefully you guys can see this. OK, good. Notice how it's like, hey, Nexus 5 connected. OK, so this is really good. I had an ADB plugin, ADB being the low-level debug interface for Android. Now it's just an extension for Chrome, so you just install it once. And it auto-detects that I have these browsers connected. In fact, I had one time where I had the tablet on one side and the phone on one side, and they're both remote debugging. It was really cool. So let me show you how this works. So let's load up a tab here. OK, this is perfect. And I only care about this one here, the local host one. So let's inspect it. It's going back through the USB, through the, here we go, ignore the errors. OK. This you probably can't see, but I'll just hold this up anyway. Just like in DevTools on the desktop, you have a live view of your application. I'll hold this try steady here. So in DevTools, I'm hovering over my container div, and you can see how it's automatically, oh yeah, exactly what happened. It highlights what that container div is here. So you have a live view on your application from your desktop. This is really cool. And that's good for things like inspecting the network loading or inspecting the elements. But we can do a little bit better. For instance, what happens if you have a bug in your system after you've compiled the JavaScript? Well, the DevTools can also remote debug. So let's go over to sources. OK. And I think I had to reload this to make this work. So stop. Come back. OK. So I'm going to wait for it to come here. OK, great. All right, so I'm looking at the source code. Sorry about that. I'm looking at the source code live off of this phone instance here of Chrome on Android. But notice how this is Dart code. Now, remember, I said this is all compiled to JavaScript and running via JavaScript Chrome on Android here. So why am I looking at Dart code in my dev tools? Well, Dart to JS, our Dart to JavaScript compiler, spits out source maps. And source maps map the original Dart code, the stuff that you wrote, to the output JavaScript, the stuff that's generated for you, because no one wants to debug the generated code. And in fact, you can even set breakpoints here. So I'm setting a breakpoint in my dev tools here, but I actually want to break on the phone here. So let's reload. And I set the breakpoint in the Dart code. And yes. OK, great. I'll hold this up again. OK, you can see that the breakpoint hit at init logging, which is some random method here I have in my Dart app. But it's really mapped back to the JavaScript. Oh. Right. Man, these Corp phones are locked down. OK, how about that? Yeah. All right. The game is not rendering. Why? Because the breakpoint is set. So I set a breakpoint in Dart code. It actually set it in JavaScript and actually broke here on the running version of Chrome for Android. That is awesome. So you can step over it just like you would normally. And if I run it, it should come up. Yes. OK, so this really is a time saver. Just connect your phone or tablet to your remote debugging sessions on Chrome DevTools, and you'll have a much faster iteration time. One final thing I should point out is that reverse port forwarding. Now, the server is running here on my local machine. I don't want to deploy this out onto the web so I can actually hit it from the Wi-Fi or whatever on the phone or tablet. I want to develop on my desktop or laptop, host the game or app here, and have this phone connect back through the USB onto this device. And so the new Chrome DevTools allows me to set up that reverse port forwarding. So on the phone here, it actually says a local host, but I've mapped that port back through. So again, it's much better to iterate this way. Just edit, reload. You get that experience on desktop. Now you get that experience on the phones or tablets as well. So hopefully you guys can use that. OK. So that kind of leads us to deployment. We've talked about the language, talked about code sharing, talked about the server, talked about the client now. What was the workflow like, and how do we get this game out into the wild? Well, as we saw earlier, the Dart VM can also be embedded inside browsers, and we embedded it inside a version of Chromium we affectionately call Dartium, and this enables some very fast iteration cycles. So for the majority of your development experience, it's edit, reload, edit, reload. So let's go over to the Dart editor here. And it's based on a stripped-down version of Eclipse, probably pretty familiar to many people. There's great WebStorm support, there's Sublime support, so hopefully there's an experience that works for you. But I want to show you the really fast edit refresh cycle. So we're just going to run this game in Dartium, so this is back on the desktop. OK, so here we go. Notice how it logged me into Google+. That's pretty cool. But let's make a change. I want to make a change to Giddy Up DevOps, I guess. So let's find that. Now, this is inside a web component. So let's just Giddy Up DevOps. See you at the happy hour tonight. Free drinks. OK, awesome. In fact, I'm just going to go over here, and I'm going to reload. Boom. So you get that great web development experience of edit, reload, no matter if it's Dart code, web components, Polymer, other random libraries, very, very fast iterations. So after you've done the majority of your testing and majority of your development, you're ready to go out into production. So you do your final testing by going through Dart to JS, the Dart to JavaScript compiler. Now, it's more than just a translator. Dart has its own semantics. Dart is more structured. And when the compiler runs, it can really act like a compiler. One of the things it can do is it can tree shake. So you can pull in libraries of any number of sizes into your application. Let's say you pull in a library with 50 functions. If you only use one function, only that one function is retained in the output of your code. So you no longer have to go look around for the smallest JavaScript library ever because you don't want to bloat it, but end up just pulling in 50 different libraries anyway. Go ahead and just pull in the libraries that you care about, use the code that you care about. Dart to JS's compiler will do the tree shaking for you. It also has really smart minification because it fully understands your application. So it outputs JavaScript code at the end. In our particular case, you saw it had, 14 packages. Not all of those were on the client. We use robust libraries like mirrors and serialization and some highly dynamic stuff. At the end of the day, though, it did a pretty good job. 166K gzipped and minified for that entire offline-online client game. To me, that's pretty good. So I'm happy with where we're at. We can always do better, though. But I think we're in a good start. So then you can do your final testing in production browser with this Dart to JS. And then finally, if you're like me, you like to deploy to the cloud. And so in this particular case, I used Heroku because they can host arbitrary virtual machines. Hey, we have a virtual machine. So the WordHerd game server piece is running on the Dart VM inside of Heroku. And I use their great git deploy and git push deployment process. So I was very happy with that. OK, great. So that's a little bit of deployment. And we're going on time. So let's talk about the lessons learned. What are some tips we can share with you guys? OK, custom elements, totally the bee's knees. But one thing that we learned is be prepared to handle or compensate for highly asynchronous applications. You saw a lot of data binding. There's a lot of lifecycle methods. So attributes can get set or unset at any time. Events can be fired at any time. So when you write custom elements, it's not like programming in Dart classes where you have a true constructor, and when that fires, you know you have those values. You have to think a little bit more asynchronously. On mobile, test on real devices, and using dev tools really, really helps. So hopefully you saw that process with reverse port forwarding and the debugging, all that, is much simpler in dev tools. When you do offline, don't develop with app cache turned on. That thing is a hardcore cache, and it will not let go. So in my particular case, my build script inserts the app cache manifest tag at the very last step when I use -- with app cache. So kind of build it into your process to add it at the very end. Otherwise, you're going to have a bad time. Dart productivity, always run with the analyzer. Now, if you use the editor, you get the analyzer for free, but those warnings and those errors that you get, that feedback, as I'm sure most of us are all, like, that's why we use languages with types, right? It is so valuable to finding errors before you compile and before you run. So if you like Sublime or TextMate, those are great editors, but I highly recommend you put the analyzer somewhere in your workflow. And finally, with mirrors, very powerful tool, highly reflective, and you can write really dynamic stuff. This is an advanced topic, so I didn't go into it, but make sure you're aware of mirrors used. This annotation tells the compiler system which parts to prune out, because reflection and tree shaking are sometimes at odds, but we do have a tool to help you work with that and actually get small output, like our game was fairly small. So when you get to this point in your development, look us up, read the docs on mirrors used. It will really, really help. So hopefully you guys are excited and you like what you saw. How do you get started with Dart? Well, we have a nice new code lab we call Try Dart. And you get to build a pirate name badge generator. And no kidding, I put in Lars and I said, Lars the captain. I did not type that. He's our boss. So, but this is a great way in under an hour, fully top to bottom, learn a bunch of Dart language and features and actually build a really fun app. So that's new on the site as well. So leaving you here with a couple points. Dart is 1.0. Now's a great time for you guys to use it. You can run Dart on the client and the server. I found this really, really compelling. Just the ability to share code is a huge win. Just to work with a fast runtime without having to compile anything on the server is a huge win. And ultimately, embrace the modern web. And we've got offline. We have Canvas. We have now good support for rendering on mobile devices. You've got, of course, a bunch of other APIs. It's a very powerful platform. And I think with Dart, it's actually now approachable by many developers like us. So hopefully you like what you saw, and tonight we have a great happy hour, free food, drinks, Angular teams and Dart teams will be there. Stop by the Google booth to get a ticket, and it's right in the venue, so just walk right outside and you're there. And hopefully see everyone there and learn more about what you guys are doing. And with that, I've got like 4 minutes left. I can take a couple questions, but thank you very much, and I hope to talk to you later today. Thank you. Any questions? Wrap it up? Yes? Does the remote debugging work on iOS? Remote debugging does work if you have mobile Safari and desktop Safari. Not through Chrome DevTools, but the same concept. Yes, good question. Any others? I'll hang out here if you want, so just come on down and I'm happy to chat. Thanks.